Okay, here's a situation. Let's say that you and two of your classmates are working on homework together in the CAS or the library or something, and you each get these different numbers for a question, and you think that maybe two of them are the same numbers, and uh, you think one of the people made a mistake and got a different number. So the question is, which of these two are the same, and which is the one that's different from the other two? So yeah, one of these things is not like the others, just like on Sesame Street. Um, so what you would do in the situation where you think you have two right answers and one wrong one, but you don't know which ones are the same, is just plug them into your trusty TI-83 or 84 calculator. I want to do the 1 over the square root of 2 first. One divided by the square root of 2 looks like that. Okay, that's about 0.707. And B, 2 over the square root of 2. Okay, that's that. And then C is root 2 divided by 2. And oh, that one also comes out to be about 0.707. So that tells you that A and C are the same and B is the different one. So it would be nice if there were kind of like a standard way of writing these things. So when somebody has something like root 1 or 1 over root 2 and somebody else writes root 2 over 2, even though they mean the same number, which one is right? I mean, they're both right, but which one is kind of like the more common way of writing it? And the answer is C. So root 2 over 2 is the standard form of this number. The denominator, 2 here, is a rational number. So what that means is that it's not a decimal that goes on forever. Here, with this one, the square root of 2 is irrational. So we call it rationalizing the denominator when we start with something like 1 over root 2 and end up with the form root 2 over 2. Let's see how to do that. With this example, we'll start with these two that have irrational denominators, a and b, and see how to write them in their standard sort of form with a rational number in the denominator. So what we want to do is we want to get it so we multiply both sides by something. We'll figure out what that is. So that the denominator that we're left with here is going to be something like, let's say the square root of 4 would be nice, because the square root of 4 is going to become a nice rational number like 2. So what's needed here in this denominator is another square root of 2, because then you can multiply these together. Root 2 times root 2 will give you that root 4 that you want. And if you're multiplying by root 2 in the bottom, you got to do the same thing in the top. So that gives you 1 times root 2, and that gives you this root 2 over 2 here. And yeah, so now we can see that we started with the version like part A we had before and did something to multiply both sides of a fraction by the same number, and the result was the standard form of part C. Now let's do the same thing with part B here. So we're going to do the same thing here. Multiply the top and bottom by the square root of 2, because root 2 times root 2 will turn that denominator into the square root of 4, and the top is just 2 times root 2, which gets you 2 root 2 over 2. One of those, and those cancels out, so you just get the square root of 2 over 1, or just the square root of 2. So yeah, that's 1.414, by the way, is the square root of 2. So that's why this is kind of a more standard way of writing it, of course, than 2 over root 2, but it is actually the same thing. So let's see some more examples of this. So with this example, of course, it's a good idea to try it yourself as usual, but I'll do it here anyways. So let's see. This is sort of not really standard form to have a fraction inside the radical. So what we do is we use the quotient rule to write this fraction as the quotient of the top radical over the bottom radical, like so. And then we don't want to have the square root of 3 in the denominator because that's an irrational number. We're going to rationalize it by multiplying by the square root of 3 on the top and the bottom. That will give you the square root of 1 times the square root of 3 is just root 3 on the top, and then root 3 times root 3 is root 9 on the bottom, which then becomes 3. So the rationalized denominator version of this number is root 3 over 3. With b, we're going to do the same idea. We're going to take the root 2, I'll just leave that alone for now, and take the root 50x. And actually, before we rationalize this denominator, you might as well simplify it first and say there's a factor of 25 in that 50. And if we simplify that first as root 25 times root 2x, so that you can take the square root of that 25 and call it 5 times root 2x, that will save a step. And also, if there's a root 2 in the top, let's write that as root 2 times root x, and that way we can cancel out that root 2 from the top. So simplifying this like this first will make it a little bit easier, and you'll be left with a 1 in the top divided by 5 times the square root of x. And then to get rid of that square root of x in the denominator, we just multiply both sides by that square root, and that ends up giving you root x over 5x, because the root x times root x is just x. And that now has a rationalized denominator. Let's do one more example actually. I'm just going to make one up here. Let's call it C, where you have a cube root. So what if you have like the cube root of 4x in a denominator under 2? Then how do you simplify that? Well, before, the goal was to get like a perfect square root in a denominator that you could take care of. Here, we want to get a perfect cube. So we're going to try to do some steps. It's not clear what those might be yet, but we want to have something like a denominator that has a cube root of, let's see, a perfect cube that we can get from 4 would be like 8. We can get that by multiplying it by the cube root of 2. And also, if we had x cubed, then that would work out nicely. So we're going to multiply the both sides of this by something to try to get this denominator. So let's see what we need. We need a cube root of 2, because that root 2 times the root 4 will give you cube root of 8. And then we want to do x times something here to get x to the power 3. So let's make that be x squared should work. So we'll do that on the bottom and the same thing on the top, so you don't actually change the fraction. And that looks like that worked. That should give you that denominator that you want. But then in the numerator, we have we can't really do anything with that. It's 2 times the cube root of 2x squared. And in this denominator, that's going to turn into just 2x, because the cube root of 8 is 2, and the cube root of x cubed is x. So that's what you end up with. Oh, and also, I should say a 2 reduces, so you can then write this as the cube root of 2x squared all over x. Okay, so there's that. Here is an exercise for you to do. It's kind of the same idea as A and B in the ones before. So try it yourself. Don't worry about getting it wrong. If you get it wrong, just cross out your answer and write the correct answer that you will see after the pause here break. There's what I got, the square root of 21 over 7. Negative square root of 21 over 7. Hopefully you got that too. And I'll see you in class.